Good evening friends, welcome to the video lecture 5 on gear trains. In the previous class we have studied one method to find out the train value and the speed of the different gears. That was a first method called algebraic method, right? So in the today's class we will try to see one more method, that is tabular method. Okay, tabular method is the most important method and easiest method to find the train value of a given epicyclic gear train, or we can able to find the speed of the different gears, right? So first we'll take again epicyclic gear train. So this depicts epicyclic gear train consists of two gears which are rotating and which are having externally meshed, right? And consist of a one single arm 3. Now we already know that the velocity ratio or speed ratio, it is defined as the ratio between the speed of the driver to the speed of the driven, or it is also is equal to the ratio of the number of teeth on the driven gear to the number of teeth on the driver gear. So here n1 is nothing but speed of the gear 1. So this is gear 1 which is rotating anti-clockwise direction, and gear 2 definitely it will rotate in the clockwise direction, because if only two gears are connected then both the gears will rotate in the opposite direction, that we have already discussed. And n2 is the speed of the gear 2, and z1 is nothing but number of teeth on gear 1, and z2 is nothing but number of teeth on gear number 2, and this is the arm 3. Now let us see the sign convention, which is very important thing here. Sign convention: if the gear rotates in a counterclockwise direction or anti-clockwise direction, its sign is taken as positive, and if the gear rotates in a clockwise direction, it is taken as negative. Please remember this sign convention, which is very important when you are solving the numericals, right? Fine. Okay, so this is about the sign convention as well as the speed ratio. And train value. Train value is what? It is just the reciprocal of speed ratio, that is n2 by n1, and here also it is reciprocal z1 by z2. Here you have to place a minus sign, because if only two gears are connected, they definitely rotate in the opposite direction to one another, right? Fine. Now let us see what is that tabular method to find the speed of the different gears. Okay, first there are 3 steps, very easy steps to follow, and we can able to determine the speed of a different gears, right? So first one, in the first column it indicates condition of the motion, that is revolution of the elements. Okay, and second is arm 3, gear 1 and gear number 2. Now in the first step of the procedure, fix the arm and give one revolution to gear 1. Remember, we are fixing the arm. See, if you are fixing the arm, then what will happen is it becomes simple gear train. The very first kind of a gear train, simple gear train, consists of only two gears which are rotating externally meshed, right? So now if we give one revolution to gear 1, what will happen is, see, this arm 3 is fixed. It means it does not have any motion or rotation, hence its value is 0. Now we are giving plus 1 revolution. It means simply one revolution. What will the sign of this? If it is plus, it means that gear A we are giving anti-clockwise rotation. Remember very carefully, we are giving plus 1 revolution. It simply means that we are making the gear 1 to rotate in the anti-clockwise direction, because it is a driver gear, right? It is rotating in the anti-clockwise direction, hence we are having a value plus 1. Then gear 2 will rotate in this much quantity, that is minus z1 by z2. What is the meaning of this z1 by z2? See here, we know that train value is nothing but n2 by n1 is equal to minus z1 by z2. This minus sign indicates both the gears are rotating in the opposite directions. Then, so here we are giving +1 revolution to gear 1. Gear 1 means what? N1, right? See, speed of the gear 1 is N1. So now in this equation it becomes 1. This is 1. N2 by 1 is equal to N2 only. N2 is equal to minus Z1 by Z2. So that only we have written here. Is it clear? Fine. So now, as of now, if we are fix the arm and if we give 1 revolution to gear 1, speed of the gear A or gear 1 is 1 revolution. Gear 2 is this much quantity minus Z1 by Z2. Okay. Next. In the second step, give X revolution to gear A and fix the arm. Okay. Here also we are fixing the arm and we are giving X revolution. Now what is the value of the speed of arm 3? Because it is again 0, simply because the arm is fixed. Then gear 1 will have a X revolutions. Gear 1 has a X revolution because we have given, see, if we give 1 revolution, the speed of the gear 1 is 1. In the same way, if we give X revolution, it means it is X. Simple, right? Then gear 2 will rotate this much quantity. See, if you are not understanding this the second step, what you need to do is just multiply X to the first row. Just multiply the X to the first row. So X into 0, 0, X into 1, X, minus Z1 by Z2 into X, minus Z1 by Z2 X. Simple. Then third row, add Y revolution to each of the gears. Add Y revolution to each of the gear, or simple words, just add Y to the second row. See, in the first row we have given 1 revolution. In the second row, to get the second row values, we are just multiplying X to the first row, right? So X into 0, 0, X into 1, X, and this into X, this much X. Now just add Y to the second row. So 0 plus Y, it is Y, X plus Y, X plus Y, and if you add this to X, it becomes Y minus Z1 by Z2 into X. Now what is the result from this above data or the table is that we have got the speed of the arm as Y. See, arm 3, speed of the arm is Y. Then what is the speed of the gear A or gear 1? It is X plus Y. Okay. When you get the numericals, you will get to know the value of this, right? And gear 2 will rotate this much speed. So speed of the gear 2 is Y minus Z1 by Z2 X. This is a very easy and convenient method to solve the gear train problems by using tabular method. Okay, we will see one question on this. Okay, we will see one question on the tabular method of finding the gear trains. So now, in an epicyclic gear train, arm carries two gears A and B having 36 and 45 teeth respectively. So now, the gear A has 36 teeth, gear B has 45 teeth respectively. If the arm rotates at 150 rpm counterclockwise about the center of the gear A, which is fixed. Remember, so here I have made the undermark. This is very important thing. Gear A is fixed. Okay. Determine the speed of the gear B. Okay. If the gear A, instead of being fixed, makes 300 rpm in the clockwise direction, what will be the speed of the gear B? So here there are two conditions. One condition is that if the arm rotates at 150 rpm counterclockwise, then what, and gear A is fixed, then what is the speed of the gear B? Okay, this is first condition. Second condition, if the gear A, instead of being fixed, makes 300 rpm in the clockwise direction, what will be the speed of the gear B? So two questions are there in the single question. So we need to solve for speed of the gear B in both of the conditions, right? So first we'll draw the epicyclic gear train. So the gear A, this is gear B, and this is arm C. which is centered at the center of the gear A. And the given data are ZA is equal to 36 teeth, ZB is equal to 45 teeth, and speed of the arm is 150 RPM, counterclockwise direction. What do you mean by counterclockwise? It is a plus, right? Counterclockwise taken as plus. Now, again, let us draw the table once again. Again, arm is fixed. Give one revolution to gear A. See, it does not mean that you always give one revolution to gear A. It does not mean that you have to give plus one revolution to gear A. You can give it to anything, any gear. But the thing is that always try to give plus one revolution to the driver gear. The one which is driving to that gear, you give the plus one revolution. Then the problem becomes very simple. Okay. So here definitely gear A is a driver, gear B is a driven, and this is the arm C. Now arm is fixed, plus give plus one revolution to gear A. Now C is fixed, so it is 0. Gear A is plus one revolution, gear B is minus ZA by ZB. So just now I have explained N2 will be minus ZA by ZB, and this negative sign indicates both are rotating in the opposite direction. Now second step is what? Multiply by x. X into 0, 0. X into 1, x. X into this much into x. Then third step is what? Just add y to the second row. 0 plus y, y. X plus y, x plus y. And this y minus ZA by ZB into x. Now we'll see the first condition. When gear A is fixed, that is the meaning NA is equal to 0. Now see, what is the speed of the gear A? It is x plus y. And he has given that gear A is fixed. It means x plus y is equal to 0. See, x plus y equal to 0 means x is equal to minus y. Then we need to find this data, gear B speed, right? Speed of the gear B is nothing but minus ZA by ZB into x plus y, or y minus ZA by ZB into x. Both are same. Now y is equal to 150. ZA by ZB is given data, and x is equal to what? Put this value. X is equal to minus y. What is y? Y is 150 because it is a given data. See, speed of the arm and this speed both are same, right? Speed of the arm is, that is y. Y is 150. That's why keep 150 here. And y minus, because x is equal to minus y. Minus 150. Then cancel these things and you will get the value 270 RPM. Is it clear? Speed of the gear B is 270 RPM. Now the second case. If the gear A, instead of being fixed, makes 300 RPM in the clockwise direction. See very carefully. Now the gear A is not fixed. Now gear A is not fixed. It is having a value now. In the first case it was 0. Now it is having a value of 300 RPM in the clockwise direction. See, 300 RPM clockwise means minus 300 RPM. Just now in the previous slide we have seen that clockwise means negative speed. So minus 300 RPM. Then what is the speed of B? Again use this data only to find the value of speed of the gear B. Now x plus y is equal to minus 300. Is it very easy? NA means what? This x plus y. X plus y is equal to minus 300. X is equal to, put this y that side. That is my 150 that side. It is minus 150. Now 300 and 150 will be minus 450 RPM. Now put it here. Y minus ZA by ZB into x. What is the value of y? Y value is 150. 150 minus ZA by ZB is nothing but 36 by 45. And x, what is the value of x? Here x is minus 450. So 450. So 45 ones are 45 tens are 10 into 36 is 360 and 150. It is plus, right? So this result you will get as a 510 RPM. This part is different and this part is different. This is case 1 and this is case 2. In both the cases we have found the speed of the gear B. Okay, we will come up with the next video with a different numerical.